So there were two different kinds of errors that probably should have popped into your mind based upon the basic concept definitions that we introduced before this. Namely that clearly, a report from some kind of experimental method might make a prediction that is not correct, or it might fail to make a prediction that is actually true. And we talked about that in terms of these two distinct aspects of sort of false positive versus false negative, right? So the question that was asked up here in the front was a really insightful question, namely, can we automatically assume that the results are guaranteed to be complete, which really is another way of saying, can there be false negatives, right? So when we talk about the results in a particular study being accurate or not, we have both of these issues to consider, and they really collide in this question of, do we expect the two lists from two separate studies to match each other or not to a large degree? The classic kind of thing that probably first comes to mind when we say, well, we think that this experimental result, is not right, would be that the predictions that it gave for, this pair of protein interacts, that those proteins might just not interact in reality, okay? And that would be a false positive. So that's probably, the single biggest concern that people have when, dealing with some kind of completely new data. Are these just false positives, or are they real, correct detections of protein interactions? But there was another big issue looming here, particularly with the numbers that were given. So, for example, when we talk about there being 6,000 proteins and the set of possible pairwise interactions, sort of 6,000 choose 2, we're talking about millions of possible interactions, right? We only detect 1,000, that only a small, tiny minority of proteins have any interaction at all. That's kind of suggestive of the possibility that these results are not complete. So we could have a situation where the two lists would have very little agreement at all, but actually every single one of those results could be a correct, real protein interaction pair, right? Why? Because if each study has a high false negative rate, then it will fail to detect most of, the vast majority of, the interactions that are detected by the other study, even though both studies are returning results that are completely correct, true interactions. Now, one core point here is that with just two data sets, we can't really resolve these two possibilities of it's all just false positives and that's why the lists don't agree, or it's high false negative rate and that's why the lists don't agree, okay? So if you raise the issue of false negatives and false positives as two possible explanations for lists not agreeing, and that then implying that just because the lists don't agree doesn't mean that the interactions reported by a given study are wrong, then that would be, a completely correct, good answer. Any questions on this?
Just less about the question itself, but more like if this had been like an exam or homework question, we only talked about like false negative. Would that be enough, or is it like we have to do homework?
Well, so the question, the main thing is read the question and make sure you're addressing what the question is asking. So in this case, the question was basically asking whether just having the lists disagree automatically means that the individual results are not real protein interactions. So in that case, talking about the false negative issue would have been certainly enough to get credit for the question.
So in general, when you ask when something should be the case, it seems to me that both high false negatives and high false positives are things that obviously do happen and we account for that in doing science, but the essence of shouldness is what is true ideally, and obviously in an ideal world, those things are low, and or if you do the same exact experiment twice, you get the same result, even if you have high false positives and negative studies. I feel like
No, that doesn't follow. If we do independent draws from some pool that's a large pool, and we take out fewer objects from that pool than's actually contained in the whole pool, and we do that on two separate occasions, chances are we're going to draw quite different things on those two separate draws, right?
okay, I guess I didn't understand the essence of the experiment that I was
Well,
drawing.
right. So when someone does a study like this of testing a novel methodology, definitely the criterion for when do you stop, right, are not typically driven by being able to guarantee that the results are complete. In other words, researchers are pretty tolerant in some cases of a substantial false negative rate, whereas a false positive rate is unacceptable, right? So that's why I was specifying when I was talking about this question that the definition of should was is it required that the lists agree in order for it to be the case that the individual protein interaction pairs are valid? Yeah, I talked about what I meant by should.
Yeah, what's the right way to compare the two hybrid results?
So you really do need to have multiple studies. So I'll show an example of what this looks like here. So this is not a made-up case. This is what actually happened in real life. So these are different, three different two hybrid studies, and you can see that they had extremely low overlap between these. And initially, this was interpreted by many people as meaning that, oh, well, that shows that two hybrids no good. These must be, the list didn't agree, so that means it's no good. But the very issue that this result could be due both to false positives and also to false negatives, that's something that takes a while to seep in, right? And you have to do more studies to assess, independently validate, are these false positives or are they real protein interactions? Okay? But just because two studies don't get the same list doesn't mean that it's false positives.
I mean, if you don't know the real interaction between proteins, how could you calculate?
Well, so I think what you're pointing out is that there's two forks that we can go, right?
Yeah.
One is the so-called gold standard, where we have an independent methodology for being able to validate protein-protein interactions. That does exist. So that's very commonly what people are going to insist on when there's a real question about the validity of the results. You can also head towards, various measures of saturation, right? Are you basically just finding the same things over and over again, implying that this methodology is saturated? It's not finding any new interactions, right? So you look at that, the saturation of how many new things you're finding versus how much sampling you're doing, okay? So that's one way to estimate, like how much is left undiscovered by your methodology. But those are the two basic tracks. Other questions? Okay. So you can take a look at the list of different kinds of problems that people have in thinking this through offline using the courselet's